My name is Keshwani. That's K-E-S-H-W-A-N-I. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 276, and today is our lesson number 24, day 24. Let's turn to page 276, problem number 19. Problem number 19. In problem number 19, we are told that P to Q is X, Q to R is X plus 2, and P to R is Y. And the question simply is, what is the question? Number 19. Which of the three angles of PQR has the greatest degree measure? Which one is the largest angle? Which one is the largest angle? Very simple, very straightforward question. The concept that they are testing in this problem is this one right here. In a triangle, in any triangle, in a triangle, opposite sides and angles are proportional. What does it mean? In a triangle, opposite sides and angles are proportional. First of all, notice that it says in a triangle. Which kind of triangle? Any old triangle. It doesn't have to be any particular kind of triangle. This does not apply. This fact does not pertain only to a right angle triangle or a acute triangle or an obtuse triangle or an isosceles triangle or an equilateral triangle. You can have any kind of triangle that you want, as long as three straight lines come together, join together, form a triangle. This fact will apply, which is the law of nature, which says that the larger the side, the larger the opposite angle facing it. It says in a triangle, opposite sides and angles are proportional, which means the largest side in the triangle, will face the largest angle, and the smallest side in the triangle will face the smallest angle. For example, let me show you a couple of them here. For example, in this triangle here, as you can clearly see, this is a very small angle. This is a very small angle, it faces a very small side. On the other hand, if you have a triangle with a very large angle, you can see this is a very large angle. Obviously, because it's a very large angle, it faces that side. And this side, as you can see, is the largest side in the triangle. This is the largest side, it faces the largest angle. What we have to figure out here is which one of these three sides is the largest side. We know this one is X, this is 2 units more than that, this one is Y. Let's find out if they have told us anything about the Y in one of the two statements. The first statement tells us, what does the first statement tell us? Oh, very good then. First statement tells us, the statement 1 tells us that Y equals X plus 3. That's it, we are done. If Y equals X plus 3, then Y is the largest side. It is the largest, this side is the largest side. And therefore, whichever angle faces the side PR is the largest angle. We don't have to figure out which angle exactly it is. That's not the point of the problem here. These are called data sufficiency questions. Nobody is asking us to actually name the largest angle in this triangle. We simply have to be able to realize that it is possible to figure out which one is the largest angle. The largest angle in this particular triangle is going to be the angle facing the PR. Now, just for our purposes, for the learning purpose, we can actually draw it. So we can have, let's see if I can draw something and see if it works. P to Q is X, Q to R is X plus 2, and P to R is X plus 3. As you can see, mine is not drawn to scale because this is X plus 2. This does not look very large, but if it were drawn to scale, let me redraw it, and it should look something like this. P to Q, let me not draw it so long. P to Q is X, this is X plus 2, which is Q to R, X plus 2. As you can see, this is a little bit longer than this guy. and then finally you have this guy, which is x plus 3. So which side is the longest side? Which angle is the largest angle in this triangle? The angle that faces the largest side being the P2R, because it is x plus 3. The angle that faces this guy is this thing. Angle Q is the largest angle. As I said already, we then actually have to do this work. It is not required for the exam. We then actually have to figure out exactly which angle is the largest angle. We just have to be able to realize that it is possible to tell which angle in a given triangle is the largest angle if somebody tells us which side in the triangle is the largest side. Whichever is the largest side, the angle facing that side is the largest angle. Because in a triangle, opposite sides and angles are proportional. The largest side in the triangle faces the largest angle. The smallest side in the triangle faces the smallest angle. So statement 1 does the job. Statement 1 is fine. So let's put down our system here. Where do we put our system? Let's erase this triangle because this was not drawn properly. Here's our system: A, D, B, C, E. And if you still do not know what the hell I'm talking about, A, D, B, C, E, it is important that you watch the introduction. Watch this video I'm going to put down here. Data sufficiency. Intro. Data sufficiency intro. Just type in my name, Keshwani, and then put in data sufficiency intro, and it should pop right up. Watch that video and you will understand what I just did here. So, since first statement works, that tells us that the answer cannot be B, C, or E. Let's look at the second statement. Answer has to be either A or a D. If the second statement also works by itself, then the answer is going to be D. If the second statement does not provide us enough information to answer the question being which angle in this triangle is the largest angle, if we cannot answer that question, then the answer would be A. Let's look at second statement. In the second statement, they tell us they tell us that x equals 2. Well, big freaking deal. X equals 2. That's not going to do us any good. X equals 2. That doesn't tell us anything. All that tells us that this guy is 2. This guy is 2, and that tells us that this guy is 4. But we have no knowledge of this guy. We do not know the third side. We cannot tell what is the third side, the missing side, the y. All we know is that x equals 2. Therefore, Q to R is 4. In the second statement, we know that P to R is y, and we know nothing about y. Just by using this information in the second statement, we cannot figure out the value of the y is, and therefore the second statement is no good. Because until we know how long y is, we cannot figure out which one is the largest side. Second statement by itself is no good. The answer is A. That's it. We're done. That's it. We're going to move on to the next problem, but before we go to the next problem, listen carefully, please. Before we go to the next problem, I'm going to do something here. We're going to go a little bit deeper into it. Just want to make sure that you understand this properly. It says, in a triangle, opposite sides and angles are proportional. Here's the but part. But not strictly. What the hell does that mean? But not strictly. Opposite sides and angles are proportional, but they are not strictly proportional. What does it mean? Well, this is what it means. To be strictly proportional would be a situation like this. For example, if somebody gives you an angle here, they tell you that this is 30 degrees, this is 30 degrees, and they tell you that let's call it A to B. Let's say A to B is 5. And they tell you that this is 60 degrees. If angle B is 60 degrees, if the side facing the 30 degrees, listen carefully, if the side facing the 30 degree was 5, side facing angle C, that's how we say, side facing angle C is AB. The side facing angle B, is AC. And similarly, the side facing angle A, which is 90 degree, is BC, B to C. Now here's what's going on. If we are told that the side facing the 30 degree angle is 5 and the side facing the 60 degree angle is 10, that does not mean that since this is 30 degrees and this is 5, this is 60 degrees, which is twice of 30, and therefore this is 10. It does not it does not imply that the angle, which is 90 degree, which is 3 times this angle, it doesn't mean that B to C is 15. It does not mean that. B to C would have been 15 if they were strictly proportional. They are not strictly proportional. They do not go in a strict ratio. All it means is that bigger the angle, the larger the opposite side, or vice versa. But it does not mean just because the angle is twice as large, the side facing that angle is going to be necessarily twice as large. You understand? If one angle is 10 degrees, the side facing the 10 degrees is 2 inches long, it doesn't mean that the side facing the 40 degree angle is going to be 8 inches long. It does not mean that. They are not strictly proportional, not necessarily. As you can clearly see here, let's find out this missing side. This is a right angle triangle, this is a right angle triangle. We can easily use the Pythagorean theorem and figure out B to C. Let's call it X. So in this case, X squared would be 5 squared plus 10 squared, and 5 squared plus 10 squared is 125. So X equals 125. X does not equal 15. It equals square root of 100. It equals square root of 125. It does not equal 15. It equals the square root of 125, which is approximately, which is a little bit more than 11. Which is a little bit more than 11. This is how we write it. Square root of 125. Notice I put down approximately, and I could have left the approximately sign had I simply left it at 11. The square root of 125 is approximately 11 because 11 squared is 121. But I put down a little bit more than 11. So then it will be silly to say square root of 125 is approximately a little bit more than 11 because that's redundant. A little bit more than 11 in itself has embedded in that statement as the implication of approximation. So we have to say square root of 125 is equal to something a little bit more than 11. So square root of 125, 121 is 11. As you can see, it's not 15. It's not 15. The side facing 90 degrees, the side facing the 90 degree is not 3 times as large as the side facing the 30 degrees, as you can clearly see there. So one more time, in a triangle, in any old triangle, the opposite sides and angles are proportional, but they are not strictly proportional. One must keep that in mind. Alright? Enough of that. I don't think I'm going to start another question today, because I think I've already taken too long talking about this concept. I will see you tomorrow when we'll do question number 20, I believe. Alright? I'll see you tomorrow. Bye now.